for you in the future. Okay, so next time we talk about the original question would be it's x1, x2 independent random variable, and then could you find the joint density function of y and y2, and then y1 is square root x1 squared plus x2 squared, then y2 is x1, x2, and then eventually I'm only asking it does y1 and y2 are independent. So in this way, you're not necessary to find the original PDF of y1 and y2. I think I did not have in my slides this time. I think eventually I'm talking about it as long as you can show that it's a g1 function as y1 and then g2 function as y2. And they're independent. I think especially you're not going to find y1 and y2's individual joint PDF. More likely you find y1 square, y2 square joint PDF. I think. Right, I think. Okay, eventually you're really proving it. I'm proving y1 and y2 square are independent. That implies y1 and the y2 are independent. Okay, you might ask me, my previous student to ask me about this. Do you have any case y1, y2 are independent, but y1 and y2 are not independent? Let me say it again, I'm sorry. Could you put on any theoretical proof telling me my y1 square independent with y2 square implies y1 independent with y2? Okay, does any special case this guy doesn't stand? I have to told you, I don't know any special case this one doesn't stand. Every PDF, every random variable you learn right now, if your square is dependent, then your y is dependent. Okay, sounds good. So I think maybe you could play around with domain things, trying to screw up something, and then eventually y1 and y2 are not independent because of domain is weird. It could be, but I'm not really interested in finding any special case to show that this arrow doesn't apply. This arrow doesn't apply. Okay. I have to say that I'm more like a biostatistics guy, even though I graduated from statistical department. Those weird cases just more interesting to mathematician, less interesting to biostatistician. Let me put it that way. Okay. You may think, oh, it's not professional. So, oh, yeah, it's not totally professional, but it's professional enough. I have to put it that way. Sounds good? Okay. So then we keep showing that it's okay because y1 is x1 squared, y1 is square root x1 squared plus x2 squared right here. So then it's much easier to do to working on the PDF of the x1 squared and x2 squared directly. Then x1 squared is chi squared 1, then x2 squared is chi squared 1 as well. So that means I'm going to change in the whole thing, I think, saying this guy's U1 and then U2. Okay, then I'm working on U1 and U2 in the transformation of y1 squared. Maybe I call V1 as a y1 squared equals to x1 squared plus x2 squared equals to U1 plus U2. And